Hello, I'm Chris Oldwood. Hopefully you're here to hear me talk about branching and you're not in the wrong talk. So I think that's it. Well, anybody else can find a way in surreptitiously. Right, so kind of, I don't know, 15 years ago, I guess, Steve McConnell coined this phrase, cargo cult software engineering, where he just came up with a sort of idea or wanted to expand the notion of cargo cults to software engineering, to talk about companies that seemed to try and adopt practices of other cool companies like like Google, I guess, or GitHub, or those kind of things, because they felt that maybe if they adopted those practices, then they would be as successful, perhaps, as those kind of companies. But they kind of do it in a way where they try and adopt the practices, but they don't understand the principles and values that sort of support those concepts, or understanding, the principles that drive them. And I think branching is one of those things that's turned into a bit of a cargo cult. So, for example, here is a tweet. This is the kind of thing, this is kind of like how the cult, I guess, kind of starts, or at least I know people that have kind of taken this. There's a tweet from somebody who's sort of quite renowned, and they kind of have a look at the sort of the slide, and they go, oh, yeah, Google's a cool kind of company. They just used Trunk for everything. They got loads of developers. They've got lots of projects. Their code changes a lot, hey, that's us, so surely we should be doing this kind of stuff again. And so they'll kind of go and blindly sort of adopt that, thinking that practice in itself will be something that will make them a bit more successful. But unfortunately, what they forget to do is they probably read the small print. So I chopped this last little bit off the bottom of that slide. And in this particular case, all the stuff before it is about the organisation part of it. And then there's this little statement at the end about the number of test cases that Google run. There's a whole load of other practices that obviously they do that also support their ability to work in this way, but they're kind of lost, and I guess by the time then most people have stopped reading if they're just going to blindly adopt something. So hopefully this talk kind of will look at some of the other stuff that wasn't sort of on the bottom of this slide. The title of the talk, if you're wondering where the title Waltzing with Branches comes from, it's a bit of a play on this particular book, which is by Tom DeMarco and Tim Lister. This book often appears at this conference on various slides. I know Seb Rose used to use it quite a lot, and that's probably why I ended up reading it. The title of this book actually comes from a song from the Cat in the Hat songbook by Dr. Seuss. And I kind of liked that sort of idea. Anybody who has children or remembers Dr. Seuss will kind of remember the sort of slightly nonsensical structure. And I kind of wonder whether actually that came about from merge conflicts, because often it seems a bit of a random selection of kind of words. Slightly more seriously, though, is the book is actually, it's often talked about in terms of project management, but the book itself is all about risk management. And that's something that I've kind of come to understand, is that branching is often used as a form of risk management. Hence, the sort of the basis of the talk is to look at branching strategies from a risk management kind of perspective, but then to look at other ways that we can, say, mitigate the same kind of risks. So branching is effectively a technique for managing risk, but it's not the only technique for managing risk. There are other things we can do. So that isn't to say that branching itself doesn't have values, or doesn't have value in other ways, and we'll kind of cover some of those. But specifically as a way of kind of like trying to solve certain problems within the development process, there's other things we can kind of do. So look at some of the risks that we kind of talk about. There's kind of two that I kind of call out. The first one is this idea, this sort of loss of productivity. Anybody who's ever worked on a code base has pulled all the latest code and then suddenly finds that it doesn't build because somebody forgot to check a file in, or they've broken the build script, or it doesn't even open in the IDE. And sometimes that's just kind of through a little bit of laziness. They didn't bother to run tests or stuff before they tried to check code in. Or maybe it's just, even the sort of the best of us sometimes forget that there's stuff outside of parts of the workspace that we have to bring in. So accidents kind of happen. Probably the worst sort of manifestations of these are the people that check something in on a Friday at 5 o'clock and then go on holiday for 2 weeks. And then you're sitting there trying to work out whether you try and hack into their machine to try and check in the files that they missed, or whether you just basically pull their code and let them sort it out when they get back from holiday. So one of the things we're trying to deal with is that sort of disruption. It's almost like the whole of the opportunity that suddenly the whole of our development process stops and tools are sort of downed everywhere as we try and sort out this kind of this problem. The second one is sort of maybe a bit more sort of woolly. It's this. It's more about our sort of confidence in the code itself, the changes. And I guess this kind of, in a sort of a classic sense, we're talking about testing. Although sort of Dijkstra teaches us that tests can only prove the presence of bugs and can't prove the absence of them, there is still maybe a bit of a kind of an idea that, do you know what, if we kind of didn't touch the code there, then maybe it's still all working. And so, branching is a way of saying, well, actually, if we don't make these changes, then everything will still be all right somehow. We kind of sort of almost maybe delude ourselves a bit into thinking that we can maybe skip doing certain things because we believe that everything's kind of still intact. So we use branching as another way of gaining confidence in our code. So we're going to sort of go through a kind of like a history sort of thing, I guess, of branching. So there's kind of like two core types really. There's private branch, which is a nice little sandpit. You get to play all by yourself. You can leave stuff broken if you like. Ultimately, it's only yourself that you're kind of shooting the foot. And then there's the integration branch, which is your it's the playground. You've got to play nicely with all the other children. You've got to get on, and effectively that's where all the sparks tend to fly. It's basically when we start putting all this stuff together in kind of a melting pot. And within that, there are sort of, I guess, I see only three real core strategies, which are kind of correspond to sort of degrees of risk. They all kind of have fancy names, and different products tend to sort of, ClearCase will talk about things in certain ways, and Git and Subversion, they'll probably have different ways for the same terminology, which kind of makes it all a bit more confusing. But kind of fundamentally, the concept should still be the same across them. Although it's kind of slightly ironic that we talk about branching strategies when branching is the cheap operation. Version control systems use the idea of persistent data structures, which means that being essentially a sort of a mutable blob of data, creating a new branch is as simple as sort of pointing to somewhere within the structure, kind of job done. Whereas at the other end of the spectrum, when we're kind of like pulling stuff together, that's when all of our problems often start, if there's a big period of time between doing it. So really what we're talking about is not about branching, it's about dealing with the merging, the opposite kind of end of the spectrum, where the problems are, trying to minimise the friction that occurs between them, either through productivity or for sort of confidence. So we're going to wind the clock back to time when I started programming 20 years ago. Tools were kind of quite simple. Branches didn't really exist. Probably did on the really big enterprise products, but I worked at a small software house. And we had PVCS, which was at the time didn't really support any branching. Everything pretty much handled in one place. Everything was stuck into one big kind of melting pot. So these days in Git, this is called master. Subversion calls it trunk. TFS, Perforce, and various other people. ClearCase call it main. So nice sort of different bit of terminology just to keep you on your toes. But basically, it's the sort of the de facto place where everybody kind of like stuffed things in. And we kind of like quite happily went along in our waterfall development cycle, chucking code into this pot. And then we kind of reached that point where all of a sudden they want to release this product and they want to stabilize it. And you end up with this code freeze. And I know that some people still have code freezes, but I guess they're generally not as popular as they once were. But we suddenly reached this point where all of a sudden there's some people who need to make some critical changes into our code, and we need things to be as sort of as stable as possible. And then there's a whole bunch of other people who aren't working on getting that product ready, and we have to find some way of them working. So either, well, all we know is they can't stick stuff in the version control system, so you'll have to use zip files or copy or whatever. You'll have to find some other way to do some work, because basically everybody's focused on getting this thing out the door. And so that's where probably the idea of kind of a release branch, which is I think is still probably one of the most popular ideas. which is where at some point in time we kind of decide to sort of take a cut of the code at that point, and then a bunch of people will work in a different kind of area. We'll finish off stabilizing features, fixing critical bug fixes, and in the meantime the rest of our people can carry on working quite happily on version 2 along the bottom, and that's good. At least we've got everybody working. Productivity is good. So in terms of excuse me. So in terms of policy, our sort of low-risk kind of release branch is very, very simple changes. They should be low-risk, critical kind of stuff. We don't sort of go around doing things like changing the compiler halfway through just before release, or tool change, or replacing backends, that kind of stuff. It's usually very, very small, very, very sort of changes, simple changes. So from a productivity perspective, it's unlikely that things will happen. They should be quite reliable. Productivity should be reasonably high. And then from a confidence perspective, obviously we'll be doing some testing, probably be doing lots of end-to-end testing, that kind of stuff, traditionally. But of course, because each change is very small, we should have a reasonably high sort of degree of confidence that all the stuff that apparently we haven't tested, hey, that still works because we didn't change the code at that point. And then kind of at the end of our product, at the end of our branch, we might sort of merge back any remaining work, critical fixes, that kind of thing that was merged. Or we might do that as we go along. The ideal strategy being that you merge from a stable branch to the more volatile integration branch. So that's kind of how sort of releasing traditionally is, in many organizations kind of still happens. When I worked at banks, there was often a whole load of red tape and bureaucracy and stuff that meant that we got to this, we ended up having to sort of push stuff off to another branch, or we'd basically sit there twiddling our thumbs. Even if you wanted to work and move things along, some other department had to sign off a load of work. And maybe that's a sign of an organisational problem, not a kind of a software development one, but ultimately we had to fit in with the way they're working, and so that kind of sort of setup makes them kind of quite attractive. So although I said there's no kind of code freeze going on in this scenario, the point at which we choose over here, we probably shouldn't be changing the compiler or changing the major parts of the tool chain just before we branch either. Part of this idea of confidence is about having, anything that's a significant change, we'll kind of probably do that way up here at the start of a kind of a project cycle, so that we can gain confidence in that tooling. Fixing those weird things that have come about, the fact that we've upgraded the compiler, or that we've upgraded all our NuGet packages and there's weird subtler interactions. We probably want to do that sort of kind of like further back rather than take that on just at the point of it, unless we have other things kind of sitting in there. Specifically, if you many of us probably work on a system where there is only one version of that, we keep pushing it forward. But if you work for something like Office or a classic product thing, or you have families, you quite often have to have various families, various versions of that product in live, and you're going to have to support those. Customers tend to be a bit unhappy about the fact that you would have to upgrade 5 versions just to get access to a bug fix to some small security issue maybe that's created as a change in some other component or thing that you've got to work with. So we might have to sort of create a tactical fix at this point in time, and so we branch from a label, which was that particular release, make the small change that we need to, and then release kind of another variation of that version. And again, from a productivity perspective, it's good. We should be making very, very small kind of surgical changes. We'll probably lean to a degree on our confidence is around the fact that we've only changed a very, very small thing. And therefore, we can kind of get away with a very sort of more reduced sort of test cycle. So that's kind of a patching. And again, we'll merge that at some point to the end. So if we think of release branches as kind of being if we think of the sort of the integration branch as our equator, then from a risk perspective, our release branch tends to be kind of up near the North Pole. And so down at the bottom, we have this idea of feature branches, or sometimes called task branches, private branches. I'm sure there's various other names in other products. But the idea is that it's all kind of a similar thing. It's all about much high riskier changes. What do we do with that stuff where we're afraid that productivity is going to nosedive, people are going to be hacking code around left, right and centre. Maybe rather than face into that, what we'll do is we'll push them out somewhere else. We'll kind of keep this work off to the side. And it might be that that particular work is a little bit messy, or it needs to be kind of kept out of the way. Maybe there's some heavy refactoring. And part of the decision to use it might be based around whether at the end of it there is anything that you're going to take out. So if you're doing a technical spike, the notion of that is that you're probably just doing an investigation. And when you get to the end of that investigation, all you really probably want is the knowledge. So rather than disrupt the development branch with loads of weird refactoring and other kind of like stuff that actually you don't want to keep, you just keep it off to one side and you can throw it away at the end. So that's kind of nice and easy. You keep stuff out of the way. If you are going to sort of take that and then take some of that code on at the end, that's the kind of the area where feature branches start to get that sort of bad name, where somebody disappears off for months on end and then kind of comes to the end and you end up with this big bang merge. It's not always just the type of change. Sometimes the risk is not so much in the work as in the person doing the work. If you're working in a team, you've suddenly been given a bunch of interns and they've never seen the code base before, maybe you're a little bit twitchy about the fact that you're just going to give them access to your main development branch sort of up front. And so you're almost wanting to keep those to one side so that you're going to have time to review what they're doing. So that's another case where feature branches are really just a way of keeping that person off to one side until you can do that. I mentioned shelving it's just a posh name for a very, very short-lived feature branch. I don't know, again, why we have to have a special name for something that really is just take this bit of code, stick it onto a branch temporarily, and then I'll bring it in. So Git talks about stashing. So again, we'll give it another name just to kind of keep everybody on their toes. And this is often where that kind of like reviewing thing comes. Even if you've broken your work down into small pieces, you just want to push it off to one side. Somebody will probably do a quick review of it, of the change, and if they like it, it'll get brought back in again. So shelving is just a very short feature branch. So if we kind of like put those things together from a risk perspective, our kind of low risk change at the top, medium stuff in the bottom, and in particular, so feature branches get their particularly bad name from this idea of this period of time might be months, weeks, days, months, and the fact that there's this kind of like horrendous kind of merge that happens at the end, this big bang merge that everybody kind of tries to avoid. And the way they have to avoid that is to ensure that you integrate onto this branch from trunk as you go along, so that when you get to this point, you should be reasonably kind of close. Your code base should be about here, rather than being some point up here months ago where the whole goalposts have kind of moved. So that's where we kind of, as we've moved along, we've got a bit more mature. That's sort of the approach that has been taken to kind of minimise this kind of like the problems that happen at this end. I'm going to mention cherry picking. It's another thing that gets a particularly bad name. And the reason, I guess, that it gets a bad name is that often you've kind of you're using this release branching, this idea of creating a release branch before the product goes out the door, and then all of a sudden somebody in the marketing department or somebody else, and he says, that feature that you've kind of only just finished in development, we want to put that into product tomorrow, and we want to put this in the release that's about to go out the door. So all of a sudden you have to suddenly pull across this code change from your development branch. And what happens is if it's a really, really simple change, maybe you just fixed a spelling mistake or something small, maybe it comes across cleanly. But often that's not the case. This change probably depends on a whole load of other changes. So you've got a whole load of changes back here that you're now going to have to start unwinding, or you're going to have to start pulling in bits of that. And it's a bit like pulling a thread on a jumper. As you start pulling it, you suddenly got to stop pulling other things in. So you end up with a real mishmash of stuff. The code has suddenly become kind of quite unstable because you've got a load of potentially half-baked stuff. You've now got to do more stabilization work, and so it can be more trouble than it's worth. But it has its uses, the ability to cherry pick features across stuff. If there are other practices that we'll talk about in a second, you can minimise the impacts. And so we kind of come to this, the sort of the Google stuff that, or the tweet that I came back to at the beginning. And for me, I found this is quite ironic, because this kind of goes back to where I started sort of 20 years ago, where when we had no branching, there were, or even if you're using a tool such as SourceSafe, which is much obviously derided for its lack of a lot of things, although you can do branching with it. You can do it, but it's incredibly painful. And so as a consequence of that pain, you suddenly find ways to work around the kind of limitations of the tooling. And there's kind of like two ways you can go. You either end up with working on your own machine forever and a day, and then you kind of like get to the end of it, your feature, and then you'd kind of push it in, and you'd have to, again, you'd be dealing with a big kind of merge, although that would just be like with your working chairs. Or the other way to look at it was to sort of say, actually, I don't like that. I don't like this idea of code sitting around on my machine. Certainly 20 years ago, Windows was even less stable than it is today, if you can believe that. And they have, and hard disks were pretty unreliable, things got corrupted and stuff. It's like, I can do backups and things, but that feels like that's the wrong way to go. It feels like there must be a better way of kind of attacking it. And so the easiest way to, or one way to do that is to sort of start breaking the change down into sort of like a smaller set of changes, rather than trying to treat this idea of a feature as being a huge set of code and edits. Let's break it down into some small bits, and let's see if actually some of those small bits we can get out the door sooner. So whenever I make a change, there's often a sort of a period of refactoring maybe at the beginning, where you start to make some changes to kind of get the code into a place where maybe you can make the change you want to do. Of course, the great thing about refactoring is you don't change the observable behavior. If you haven't changed the observable behavior, you've not broken anything, so why isn't it in production the moment you've done that? So first of all, any refactoring we can do, we can get that in, we can push that out the door. Great, we're starting to get some value. I say value in a loosest sense of the word, but effectively, other people can see that refactoring, they can see where it's going, but also we can kind of start, that code is in production, it's great. So then 1B is me saying, well, I'm kind of probably going to want to add some code as well. Maybe I'm, as part of this new feature I'm adding, I'm going to add some stuff. Well, if it's not accessible, then whilst I'm adding stuff, it's still not accessible. So I can still kind of push that code, and it can still go into production because nobody can see it. I mean, there will come a point where somebody's going to want to make use of that feature, or I'm going to have to tie it in such a way that that feature does become usable. And that's where the idea of feature toggles comes in. So that you have the ability to switch it off. By default, this feature will be switched off, and then there's some way of turning it on. It could be if-defs, or it could be configuration, environment variables, configuration settings. It could be things that you pass in the request, secret query parameters. Many different ways of kind of like turning that behavior on. But we probably even just want to turn that behavior on for a select bunch of servers, or a select bunch of users. And then you kind of open yourself up to the world of A/B testing, which is obviously quite a popular way of testing, looking at features and kind of bedding them in. So there's sort of this period at which we sort of almost transition the last bits of that change in, we turn it on, and then we kind of get to the bit at the end where all of a sudden we've features in production. Two things have happened. One of two things will have happened. We've either accepted the change, that's great, in which case we can start to throw away all the code that we have basically replaced, or maybe it turns out it didn't work and we need to throw that code away. But either way, we kind of need to have this extra step that we kind of clean up after ourselves. And that cleaning up thing is quite important. Often it's very easy to sort of leave that stuff lying around in a code base. And kind of what you get out of this sort of approach is that obviously because everything's done in a kind of a very sort of small manner, we're sort of this notion of sort of always being ready to ship. The code base is kind of always in a sort of a state where at any point we could sort of potentially pull off a release, because we're trying to sort of keep it as production ready all the time. We don't just disappear off for a bit and come back. We're trying to keep. And obviously we're sharing our changes with everybody else around us. Everybody can see what's going on. So I don't know whether anybody said this formally, but to me, when people talked about continuous integration, to me it's always been a mindset. It's about a way of thinking about delivering code changes to other people. Rather than it's not this tool, it's not because I've got a CI server somewhere, that doesn't necessarily mean I'm doing integration. I know people that do have a CI server, and they have a bunch of separate release branches with separate or feature branches, and they bring them to the end. That's kind of not to continuous integration to me. It's more about me sharing what I'm doing with other people, pulling what they're doing, on a continuous basis, so that I can see the world as it's moving, every sort of, it could be minutes or even half an hour or an hour. I'm always twitchy when I've sort of gone a couple of hours and I maybe haven't pulled the latest code. I'm getting very nervous because I'm thinking, somebody might have changed something that's important to what I'm doing. So I think that this idea, that using trunk and then kind of no branching approach, for some people that's a bit new age, a bit modern. It's quite a pessimistic, quite an optimistic approach to development, in the sense that you're facing into the fact that people might break stuff and that things might not work, and you've got to be prepared to kind of fix that up there and then. And maybe you take the fact that if the production line stops for a few minutes, people just jump on it, and you're in a culture where that will happen, then that's great. Because you'll get back on track and you'll have some of the other things that we'll talk about behind you to kind of like watch your back. But there are other organisations with huge volumes of people, and they want a little bit more security than that. But they want that security, but somehow they want to do that in a way that they don't suffer the classic problems of a feature branch, which is continually emerging from the integration branch time again, and the fact that at the end of it there might be to avoid that sort of big bang thing. So so gatekeeper workflows have become quite popular. And I think they're becoming more popular because of the tooling that sits around them. And the idea is that our trunk, effectively, nobody's allowed to commit to it apart from our gatekeeper, this GK. That gatekeeper could be a real person, or it could be a tool. It could be all automated. And effectively, everybody else works off to one side in a kind of a sort of a classic feature branch kind of environment. So Alice and Bob work in completely separate branches. Every now and again they'll pull changes up from trunk or down in the case of Bob, do a little bit of work, make some changes, and then at some point their changes will be merged into the trunk. So in the case of a manual case, that might be somebody has to review the code before it happens. There might be some certain things have to run, code quality analysis, tools, that kind of stuff. Before the code will be accepted. Or in an automated case, it might just be a case of, there is a tool that runs, that pulls this code out, builds it, automatically tries a merge. If that works okay, then it'll run the tests, and if they all succeed, all these other kind of processes happen. And if at the end of it, if all that succeeds, we go, well, that's good enough to commit that change. Because although it might not be exactly right, at least we know it's not going to screw everybody up, and we're probably pretty confident that it's the same kind of change. My own reservations are this, and I know other people are, is that it is unless you kind of have that, maybe that automatic, the tooling aspect to it, it doesn't kind of give you it's easy for people to kind of to fall back on that, not doing the pull from trunk quite so often, and then things get a bit more kind of disruptive. So that's why I say it's more about a mindset. You kind of either face into it and go, do you know what, I'm going to pull stuff, and if things break, then hey, I managed to point it out straight away. Or I could be, no, I want to keep everybody else's changes away from me because I don't want to be the one to have to deal with that or point that stuff out. So, and I don't think it I don't think it gives you the same. I don't think you face into it in the same way. So what are some of these things that we've mentioned? I've already mentioned that on the bottom of the slide we saw testing or automated testing as a thing. So there's definitely a number of things that we can do to kind of make sure that code is in a kind of a suitable that is the confidence aspect of what we're trying to achieve. And that's doing things like pair programming, obviously, code reviews, design reviews, kind of continuously, all the collaboration aspect, basically all the people stuff that we do. That plays a huge part on kind of like quality before the checkers, the changes even got into the branch, before we've sort of pushed it to the outside world. We're pretty confident. There's a lot of sort of manual stuff that we can do about that, and that has a significant effect on the quality of the code. And obviously, from a confidence thing, many eyes kind of make a lot of this stuff, buys us a lot of kind of confidence. That's one side of it, but obviously the biggest side of it is probably the automation part. writing tests that run, that can easily be run, where you can run a barrage of tests the moment everything changes. Not long ago, when you perform a commit, you'll have some server that will pull all the code out, run a whole barrage of tests and stuff. That's a really great feedback loop of a matter of kind of, could well be, should be minutes or so. Whereas now, even tools like ncrunch and stuff, where almost as you're typing at the keyboard, things are happening underneath it, and you're kind of like your feedback loops kind of milliseconds, is a kind of insane sort of level of feedback. And obviously it's that building that automation. So building big suites of tests, making full use of acceptance, unit tests, acceptance tests, performance tests, and then making use of other tools, tooling, I guess so things like Docker, trying to get as much of that product so that, within a very short period of time, you've got a really, really high sort of level of confidence about what it is you're doing. And it takes time, but it takes time to build, to get that stuff in place. But, there's so much tooling out there to make that possible. So I suppose the moral summary of this kind of thing is that for me, branching can be used as a way of kind of managing risk, but it feels like it's a bit of a woolly proposition. And actually, we should spend a bit more time investing in some of the other techniques, in the people, in tooling and process to kind of to counteract that, so that we find other ways of being confident about what we're doing. But that isn't to say that there aren't reasons why we might want to take certain approaches. Technical spikes, being able to throw a branch away is actually, a really good way of keeping a lot of noise out of a branch. But we have to decide what it is we're trying to do, whether we want the end result. So it's a balance. That's it, really. So, questions? Stunned silence. Given how contentious a topic is, there's either people who are sitting there fuming at this point in time, or maybe it was too ambiguous, or too. Yes, sir. I mean, they have one repo. Yeah, but that doesn't mean to say that the code base is all lumped in. Presumably they actually have some structure in place within the code that people work on different parts of it. But it is one repository, yeah. So they have some stuff. There was some recently blog posts about the dependency work they were doing about the dependency checking. So, they've got 100 million test cases. That takes an awful lot of time to run. And in a lot of cases, just because a library's updated doesn't necessarily mean that they need to run 90 of those million of those tests. It might be that only certain components can actually use that actual function within a particular class that actually changed. So having it in a big repo, they've managed to build some tooling that does dependency analysis to work out, well, actually, there's only a subset of things that actually depended on that particular change, not just that library, but that particular change in that class. And I think that's one of the things why it's being sold as an interesting idea of sticking everything in one box rather than in one repo rather than having kind of many. Sorry? Good. That's it. I don't have a book to plug. Blog posts and puns for those of you who saw me on Wednesday. That's about all I got to offer. So, cheers.